Today is 11th November 2024, sorry 2025, and it is our second class on deformation at Excel physics. In the last class, we have started a new formula sheet in which we have discussed questions on Hooke's law, then we have calculated stress, we have calculated strain, and now the last question from your book for Young modulus, and then we will start original past paper question. The question is, you are given a copper wire and its diameter is 0.22 millimeter and it is stretched by force 100 Newton. You are given force, you are given diameter, and they are asking what is the Young modulus. Sir, Young modulus is equals to stress divided by strain. So sir, first we have to calculate stress, and to calculate stress I need force. Sir, force is given, no issue, but we are not given area. Force per unit area, it is called stress. So we are not given area. Sir, how do we calculate area? If you have to calculate area, then area is equals to pi r square. The value of pi is 3.142. We are not given radius, but we are given diameter. If you half this diameter, 0.22 is divided by 2, obviously it will give you radius. It will be 0.11 millimeter. 0.11 millimeter, and millimeter means exponent minus 3. So if you solve pi r square, then you can calculate area. Area is 3.80 exponent minus 8. So diameter is halved to calculate radius, and then I calculated area by pi r square, and then we have to calculate stress. Stress is force per unit area. Sir, force is 100. Area we have already calculated. Very simple question, so I am not wasting your time. So stress is equal to 2.63 एक्सपोनेंट 9. बेटा बनी एक मरतबा लिख लीजिए ताकि ये फॉर्मूला आपकी रनिंग में आ जाए. ठीक है, स्ट्रेस इज इक्वल टू फोर्स पर यूनिट एरिया. फोर्स वी आर गिवन. एरिया वी हैव कैलकुलेटेड बाय stress over strain, and stress is 2.63 exponent 9 divided by strain, and I think strain we have calculated. No sir, we have not calculated strain. Sir, we are given a diagram. This is the diagram. In this diagram you are stretching the rod by 100 Newton force, and if you are stretching, then this stress is called tensile stress. If you are compressing, it is called compression stress. If you are stretching, then it is called tensile stress. So we have calculated tensile stress, and now I need to calculate strain. So what is the equation of strain? Sir, strain is denoted by this symbol, and strain is extension divided by original length. And if you look at the diagram, so the original length is 1.76. Sorry. Original length is 1.76, and extension. So this is the extension. This is the extension due to the force, and extension is 0.04. And if you divide these two numbers, then the strain is 0.023. 0.023. And now you have calculated strain, you have calculated stress, and their ratio it will give you Young modulus. Their ratio it will give you Young modulus. So we have done this question from your book. This is very easy question. And now starting past paper questions. Starting past paper questions. And we have discussed all these graph in the last class. Now the first question is from graph. And in this graph, sir, what is happening? So I'm explaining you. If you plot a graph between stress and strain, so remember stress and strain are directly proportional to each other. So the graph between stress and strain is a straight line, but this straight line remain a straight line up to limit of proportionality, the point up to which the graph remains a straight line, then this force or this stress is called limit of proportionality. And remember, after limit of proportionality, there is a point on the graph which I cannot predict. I have no idea where will be this point, but this point is called elastic limit. Elastic limit is the point on the graph which lies either just after limit of proportionality, and sometime limit of proportionality and elastic limit may be at the same point. So we have no any rule. But consider elastic limit is just beyond limit of proportionality I have drawn. And the question is, sir, in which graph there is a low elastic limit? So sir, this is very high elastic limits, and I think this is low elastic limit, and this has low elastic limit. So option A and B are out. Why? Because their elastic limits are very high, and we are searching low elastic limit. So low elastic limit lie in option C and D. Okay. And now they are asking the second condition. There should be large plastic deformation. Sir, what is the meaning of plastic deformation? So the answer is in this graph you can see the red graph. This is the red graph. This is the red graph. The red graph up to elastic limit. Then this graph is called elastic region. It is given. The red region is the elastic region. From origin to elastic limit, the graph is called elastic region. And the region beyond elastic limit, it is called plastic region. So you can say from point B to point E, this is plastic region. And it is clear that this is plastic region and this is elastic region. This is plastic region graph. This is elastic region graph. And in this question, they are asking, sir, large region of plastic deformation, sorry, large region of plastic deformation. So if you measure, sir, this is a very long plastic region. Whereas in option D, having low elastic limit, but its plastic region is very small. So the right answer is C. In this graph, we are searching low elastic limit. These are high elastic limits. C and D having low elastic limit, as well as large region of plastic deformation. So large region of plastic deformation in option C. So this is very simple question. We should not stay more. And now next question. Acha ji. This question is from June 2019 paper. This is a question from June 2019. And in this question, you are in a lab, physics lab, and you are calculating young modulus of this copper wire. This is a copper wire, and now you have to calculate, you have to determine its young modulus. Okay, and you are given a ruler, or this is a ruler or a scale on which there is a marker, and this marker shows how much extension. If you add load here, then obviously this pointer will move towards right side, and this pointer move towards right hand side. Why? Because the wire is extending. If the wire is extending, then obviously you can note down the marker position, or you can connect a pointer with along a marker. This is a pointer, and this pointer is moving on the scale which shows how much extension in the copper wire. Now the question number one, how do you measure the diameter of wire? Okay, this is a lab question. This is not a theoretical question. They are asking, if you are in a lab, then how do you measure the diameter of the wire? So I believe you know this device which is known as micrometer screw gauge. I am trying to draw. This is micrometer screw gauge. And in this micrometer screw gauge, here are two studs. Here are two studs. This stud is fixed and this stud is movable, and you can move this movable stud by turning this drum. This drum is rotatable. You can rotate this drum, and I will share you a video from YouTube in which a teacher is in the lab and performing this experiment so that you can visualize what I am saying. But right now this is a drum, and by turning drum you can move this stud. And consider you have a wire. This is a wire. Consider this is a wire, and you are interested to measure the diameter of the wire. Consider this is a wire, and you can fix this diameter between the two studs. This is a movable stud, this is a fixed stud. So first you will fix the wire between the two studs, and then you will note down the readings. Actually, here are scales. One of them is called main scale, the other one is called circular scale. But you do not write in detail. Just you have to write fix wire between the two studs and note down the reading on the scale. And this reading will show you its diameter. Okay, number one. Number two, in to increase its accuracy, we take at least three readings, and these three readings we take by changing the position of the wire, the orientation of the wire. So if you change the position of the wire and take three readings, and obviously you will take its average, then you can calculate the diameter of this wire. So I will share you its answer which I have written in my writing. But if you read the marking scheme, the marking scheme is here. We will use a micrometer screw gauge. Okay, fix the wire between the two movable studs and note down the reading, and take three readings at different orientation, at different positions along the wire, and then calculate their mean. It will be the diameter. But I have already written this question answer in my own writing. I will share you just after my class. So I have explained you. I think it is a very simple explanation. And now the main question is here. This is the main question. Sir, in this question, this is a load, this is extension, this is a graph, and this graph is a straight line. I think up to this point. I think up to this point. Because if I extend this line, then it is not meeting on the line. So this is, I believe, this is the limit of proportionality. Limit of proportionality is the force up to which the graph remains a straight line. Okay, and what is the question? The question is determine Young modulus. You have to calculate Young modulus. Okay, so I'm writing the formula. Young modulus is denoted by E. Sir, why do you not write Y? Y should be Young modulus. Actually, its original name is modulus of elasticity. Modulus of elasticity. So we are calculating its elasticity. That is why it is denoted by capital E. And its formula is force per unit area, extension, original length. Okay. And now I'm trying to fill the values. Sir, force and extension. These two values we should select from graph, and graph only for the straight line portion. Why? Because if we are calculating Young modulus, then Hooke's law must obey, and to obey Hooke's law, the graph must be straight line. So the graph is a straight line, and pick a point on the line which is easy to read. which is easy to read. I believe this point is easy to read, and on this point, if I ask you what is the force, sorry, what is the extension? So the extension is 2.5. You can pick any point, okay? So this is the extension, and what is the force? So force is here, okay? And I think the force is 5.2, 5.4. I think it is 5.6. I think it is the third division. Let me check. Uh, Let me check. It is 5, 5.2, 5.4, 5.6. Yes, it is 5.6. So I am right, it is 5.6. And if it is 5.6, so I am putting the values. Sir, force. Sir, force is 5.6 Newton. You can choose any point on the graph. Force from the graph 5.6 and the corresponding extension is 2.5 millimeter. 2.5 millimeter. This is the extension. And what is the original length of the wire? Original length of the wire is 2.4 meter. And what about area? Sir, area you can calculate by pi. Pi value is 3.142. And then r square. And sir, r will be half of the diameter. So diameter is 2.3 exponent minus 4 divided by 2. Okay. So if you put all these values in this formula and now use calculator, and then can someone tell me what is the answer? In the marking scheme, the answer is sir 1.27 exponent 11, and the unit of Young modulus is just like unit of pressure, unit of stress, that is Pascal. So the unit of Young modulus is Pascal, and the question I believe is very simple, in which you have selected force and extension from the graph, force and extension from the graph, and then length and area we are given values. So we have calculated Young modulus. जी बेटा, have you calculated? Okay, ठीक है जी, ठीक है, क्योंकि बेटा मैंने कुछ और वैल्यूज ली है, मार्किंग स्कीम वाले ने ग्राफ पे से कोई और सा पॉइंट उठाया हुआ है, ठीक है ना? तो सब कुछ सही है, तो बोथ आर ओके. एंड नाउ we are solving the next part of the question. So the next part of the question is, if you are in a lab, then you are given a sample of wire, okay, and if this sample of wire is long and thin, then student can measure Young modulus easily. And conversely, if the wire is short in length and thick, then it is very difficult to measure Young modulus. So the question is why? The question is why? So now I am explaining you. So the explanation is, sir, for Young modulus, I need force per unit area, and area is pi r square, length and extension. Okay, we have to calculate Young modulus. So I need these four variables. Okay, you can see in this equation this length and delta x. If you shift delta x here, then you can see delta x is directly proportional with length. So what does it mean? If you use a long wire, then there will be longer extension, and longer extension is easy to measure. If the extension is very small, then obviously pointer movement, this marker is a pointer, and this pointer is moving on the scale. So if the reading is very small, then it is very difficult to measure. It is difficult to measure. So extension is directly proportional to the length. If the wire is long, there will be extension which is measurable, and if the length is small, then it is their extension will be very very small, and sometimes you do not find any extension. Actually there is extension, but the value of extension is so small, it is very difficult to measure. So if the length of the wire is long, then you can measure extension easily. So the first thing, extension is directly proportional with the length, so long wire is easy to measure its extension. Number one. Number two, for the thin wire, for the thin wire, so for the thin wire, if I shift again this delta x on the other side, then extension is inversely proportional with the area of cross section. This pi r square is area of cross section, and area may be thick, may be thin. Okay. So if the area is thin, the wire is thin, area of cross section will be small, then again it is easy to stretch. It is easy to stretch. And if it is easy to stretch, then obviously it is easy to measure. Then when the extension is long, then it is easy to measure. So in both example, I am expecting and I am wishing a delta x should be long enough. And if it is long enough to, then it is measurable. Otherwise, sometimes delta x is very small, the extension is very small, it is not measurable. So if the wire is long as well as thin, then at low force, at a small force, because we are hanging load and this load is not 5 kg or 10 kg load. Okay, this load is not 5 kg or 10 kg load, it is hardly 40 gram, 60 gram, 70 gram. So this mass or this load is very small, and if the load is very small, then obviously extension is so small, it is very difficult to measure. So I think I have explained what is the reason, but if you read the marking scheme, then I think it will easier to write answer. And again I will ask Manahil to write answer just after my class, and you must share in the group. हाँ बेटा बोले. Okay. Actually for the longer wire, extension will be larger. For longer wire, extension will be larger. Okay. And if extension is you can say extension is proportional to the original length, and you can see it is not directly proportional. Directly proportional means extension will be changed at the same rate. Okay, so you should not write directly proportional, you should write only extension is proportional to the original length. And for thinner wire, extension will be larger, so we can say extension is inverse relation to the area of cross section. So it is easy to measure, and a small load can be used for long and thin wire. And if delta x is measurable, if delta x is measurable, then the percentage uncertainty will be lower. Uncertainty, or you can say error, error will be lower. But the correct word percentage uncertainty, in the last classes I have explained you what is the meaning of uncertainty. But if extension is measurable and it is noticeable, then percentage uncertainty will be lower. So I hope I have explained properly. And just after my class, if you have a time, then you should write the answer. But सिमरा आप हमें आंसर लिख के भेजेंगी सिमरा? You should write answer so that you have practice how to write these kind of answer. Simra beta, will you write just after my class? Simra? Okay. And now I am moving forward to the next question. And this question is completed. Okay. This question is completed. So now I am starting a new question. This is October 2019, and this question graph is no straight line and quite क्या बोलूं इसको. खैर, the question is concrete is a material often used for a building. ठीक है जी. So you are given a stress and strain graph for one type of concrete. Avada Simra, do you know what is the meaning of concrete? Do you know the meaning of concrete? Okay. So concrete is a type of material which is used in the construction of building. The positive values of the strain represent compression. Okay. When you are compressing, when you are compressing uh, concrete, then positive values of strain. And if you are compressing the positive values, and for stretching it has negative values. Okay, you are given this condition. This is positive values for compression. If you compress concrete, this is the graph, and if you stretch, then this is graph. Okay, what is the question? The question is, explain how the stress strain graph shows that the concrete is more suitable for under compression. It is a 2 mark question. Okay, more suitable for compression. Okay, so you can see a material is considered good if it can bear high stress values. So if you compare this stress and the maximum value of stress, sometime it is known as UTS. UTS means ultimate tensile stress, or sometime ultimate compressional stress. So it is the maximum value which is generally known as UTS. So this is the maximum value, and the maximum value of stress in compression is high, and the maximum value of stress in stretching is low. Okay, so only I have to comment this, sir. If the value of stress which concrete can bear, if this value is high, then obviously it is more suitable. So I think yes, you should write answer in this way: breaking or ultimate stress. The better word is this: ultimate stress is much greater under compression. You can see in the graph. Abdullah beta, I will ask you this question and you have to explain. The question is very simple. No mathematical work is required. Sir, for compression graph, the value of ultimate stress is high and the value of ultimate stress is low in tensile. So, ultimate stress is much higher under compression. Its value is 40 megapascal as compared to compression, sorry, as compared to tension, which is just 10 megapascal. So this comparison shows that the concrete is suitable for compression. This shows that concrete is suitable for compression. 1 mark for values and 1 mark for comparison. Okay. हाँ बेटा अब्दुल्ला, why concrete is more suitable for under compression? Why? अब्दुल्ला, हम चेक करेंगे आप सो रहे हैं जाग रहे हैं बेटा? अब्दुल्ला हमें बताइए. अब्दुल्ला, आर यू देयर? अब्दुल्ला, सिमरा बेटा, अब्दुल्ला, is he in class or not? He is in call but not replying. अच्छा बेटा चले सिमरा आप हमें एक्सप्लेन कर दें why a concrete is more suitable for compression. Question is very simple. जी सिमरा. For compression, this stress is very high. For stretching, stress is very low. So it is suitable for compression. जी बेटा सिमरा, can you say something? For concrete, but both are concrete beta. The whole graph is for concrete. The stress is very high for compression of concrete and it is very low for stretching. So it is suitable for compression. हाँ बेटा सिमरा कोशिश कीजिए दोबारा बोलने की. हाँ जी. यस. एंड आई थिंक आई शुड राइट आंसर बिकॉज आप उसको आंसर कर नहीं पा रही बेटा. सो आई एम राइटिंग आंसर. बेटा आंसर लिखिएगा. अल्टीमेट. अल्टीमेट मीन्स मैक्सिमम स्ट्रेस. अल्टीमेट. अब्दुल्ला आर यू इन कॉल बेटा? Ultimate stress is much greater, that is 40 megapascal under compression as compared to. Now we are comparing as compared to under tension, which is just 10 megapascal. So concrete is more suitable for use under compression. Okay. So हाँ बेटा नोट. हाँ हाँ बोले बोले. नहीं नहीं. टेंशन वाली भी अगर हाई होती ना. टेंशन वाली भी अगर हाई होती. टेंशन वाली भी अगर हाई होती तो हम कहते हैं कि फॉर एग्जांपल ये ग्राफ यूं होता. मैं एक और यूं बना के दिखा रहा हूँ आपको. ये ग्राफ चले यूं होता. ठीक है. अगर यूं होता बल्कि इसको और ज्यादा बड़ा बनाने में. अगर ये यूं होता. ठीक है. तो मैं कहता कि टेंशन में कंक्रीट ज्यादा स्ट्रेस बर्दाश्त कर सकता है. ठीक है जनाब. अगर मैं कंक्रीट को खींच रहा हूँ. ठीक है जनाब. तो ये ज्यादा स्ट्रेस बर्दाश्त कर सकता बिफोर फ्रैक्चर. तो मैं कह देता कि टेंशन में इट इज बेटर. ठीक है जी. लेकिन उन्होंने क्वेश्चन में हमें क्या बताया कि यू आर गिवन टू ग्राफ. पर यू आर गिवन टू पार्ट ऑफ द ग्राफ. यू कैन सी इन कंप्रेशन stress value is high. In tensile stress value is low. So it is better in compression. जी बेटा. बनी बात समझ में आई? ठीक है. बस दोनों को कंपेयर करना है किसमें ज्यादा है. जिसमें वो ज्यादा बर्दाश्त कर सकता है और नहीं टूट रहा तो ऑब्वियसली उसके अंदर वो बेहतरीन है. ठीक है. और टेंशन में तो आप देखिए ना. टेंशन में वो टूट जाएगा. इससे ज्यादा बर्दाश्त कर ही नहीं पा रहा. 10 से ऊपर ग्राफ गया ही नहीं है. तो 10 से ज्यादा अगर आपने डाला तो वो फ्रैक्चर कर जाएगा. टूट जाएगा कॉन्क्रीट. अच्छा जी. And now this is the mathematical part of the question. The question is a steel rod has diameter 45 millimeter. अच्छा, it is not a concrete question. ठीक है. Now the situation is changed and this is a graph for steel. This is a graph for steel. Stress strain graph for steel. A steel rod has diameter इतना. Okay. Calculate maximum force. You know maximum force corresponding to maximum stress. Okay, we are given diameter. If they are asking calculate maximum force that could be applied to the steel rod before it fracture, then you can see where is the maximum stress. But Banin, can you read what is the maximum stress? And remember along y-axis this is stress. What is the maximum value of stress? I am not marking on the screen. Yes, you are right. You are right. Okay, because this is the peak value of stress. It is the peak value of stress. So you are calculating force. You know force per unit area is equal to stress. And if you are calculating force, then force is equals to stress into area. You know area is a constant quantity. If I use maximum stress, its another name is ultimate stress. It is its proper name. So I should not write maximum. I should write ultimate stress. If I use ultimate stress, then it will give you maximum force. Okay. So we are calculating maximum force, and as Banin read it, sir, it is 5.1. It is 5.1. Okay, I am counting. It is 5. It is 5.2, and she is saying it is 5.1. I am using the value. It is 5.1 exponent 8. And what is the area? Sir, we are given diameter. We are given diameter. So area will be pi r square, and r is equals to half of the diameter. And it is in millimeter. It is in millimeter. So I use exponent minus 3 with square. So the question is very simple. We have extracted the value of ultimate stress and it is multiplied with the area. Then you can calculate maximum force. What is the maximum force if you calculate? In the marking scheme, sir, it is 8.03 exponent 5. And beta Banin, what is your answer? 8.11. Okay. Exponent 5 Newton. So this is also a very simple question in which you have to find out the maximum force and maximum force corresponding to the ultimate stress. Ultimate stress is multiplied with area. Then you have calculated maximum force. Okay, this question is completed. Zabardast. We have solved two questions, Alhamdulillah, and both questions I believe are simple. And now we have an objective which you should solve. Okay. हाँ बेटा आप लोग इसको सॉल्व करें एंड आई थिंक आई शुड स्टॉप रिकॉर्डिंग बिकॉज आई एम आस्किंग यू टू सॉल्व इट ठीक है जी रिकॉर्डिंग बेटा मैं बंद कर रहा हूँ